we're going to look at a customer use case around automation and the integration of IP Fabric into their wider operational ecosystem. Now, this particular customer is a large engineering organization, European based. What they're really interested in doing is accelerating their journey towards network automation. They've got a large environment based over many sites, different network platforms in different domains, network domains. And what they want to be able to do is have that central view and that central automated approach to building and deploying and supporting their network. They chose an approach to use open source tools where possible, but obviously in some cases that's not necessarily the best fit. They started off, obviously, as everybody does, with a network, and that network was built and maintained and operated using configurations that had been built from templates. Those templates being developed over time for all of their platforms, and really stored as text files with data that was cut and paste from other places in order to deploy them. Now, the first step really was to look at how to push those templates into the network, and so they chose to use Ansible as an automation framework to build those templates as Jinja 2 files, and then obviously there's data that needs to be put into those templates in order to be rendered into configurations. So they chose a source of truth platform. In their case, it was Netbox, to store information about VLANs, VRFs, IPs, and so on. As you can see, really the data that's needed to operate as the variables really in the templates that are deployed through those Ansible playbooks. And so you can see they've built there a mechanism of defining the information in the source of truth, of then using that information through their automation framework into creating the configurations that need to go into the network. But it leaves a space, really, an element that's not dealt with, and that's taking the network information and making sure that it's pushed back into the source of truth so that the source of truth actually reflects what is in the network, both initially and during normal operation. There was a further complication in that change in their network could be executed from a number of different places. You might modify the data that was in the source of truth and expect that to be pushed through the automation platform and into the network. The templates themselves may be updated within the automation layer, and so have to be re-rendered and again pushed into the network, or in some cases there may be manual change needs to be accommodated within the network itself, so maybe for troubleshooting perspective, or maybe certain operational process that needs that to happen. As a result, the network data that results from that needs to be synchronized back to the source of truth in order to maintain the integrity of the system. But there's a bit of a gap, and so that gap was filled using IP Fabric. So IP Fabric gave the customer visibility of their network from day one, and that creation of automated documentation that meant they were able to understand what was going on in their network through the interactive UI. But of course, it has an API too, and that API could be used potentially to update the source of truth. Now, the thing with that is you could take the data from an IP Fabric snapshot and you could just push it straight into the source of truth, and that would be job done. But that's problematic potentially, because what if you had a situation where stuff was removed in error from the network, or there were a connectivity issue at the point where IP Fabric ran its snapshot, and so it didn't actually capture all of the information about the current network state. If you were to just take the information from IP Fabric and push it straight into Netbox, or indeed remove things that were no longer in the IP Fabric snapshot, you'd end up in a situation where the source of truth would go out of sync and essentially not represent what the network either either looks like in real life or was intended to be. And so what the customer chose to do was two things. They chose to use IP Fabric in order to determine what changes were happening day to day through the network, through the snapshots, and creating reports of what those updates were, additions and removals and so on. And then use that reporting structure to actually choose whether or not to push data into the source of truth, or indeed remove stuff from source of truth, which is perfect for the scenario where devices are being removed or devices are being added, to keep that inventory up to date. All good. But there are some scenarios where perhaps you do want to just push changes through automatically. If you have interface descriptions that are changing, if you have IP addressing allocated to devices or interfaces that you don't need to be concerned about overly. And in that case, you could create automated changes to just directly update the source of truth regardless. And so you have these two approaches to using the data from IP Fabric. Once our source of truth is installed into the network, we need to create that initial load to get the data from the network as it stands and push it into the source of truth, so that the source of truth actually represents the network as it is. IP Fabric is busy harvesting the data from the network. Every snapshot, it goes ahead and pulls all the inventory data, all of the interface information, all of the configuration, all of the state that's in the network, day after day after day. Using a Python script, we can extract that data from IP Fabric and potentially use it to update Netbox. For the initial load, the Python script will make a call into Netbox to see whether there is an inventory at all, whether there are any devices installed. If there aren't, it'll go ahead to IP Fabric, it'll pull the inventory data out, and it'll pull the configuration data out for interfaces and the like, and then run an API call back into Netbox in order to push that data into the database there. Simple. The team just happened to be using WebEx Teams as a communications tool, and our script will send them a message too via the WebEx Teams API to say that's been completed, go have a look. Now, in order to maintain that data, IP Fabric is still continually polling the network, but what it will do is every time it creates a snapshot, IP Fabric will send out a webhook. Now that's a simple HTTP post request. And what we'll do is we'll use our Python script to take that request and process it in some shape or form. Initially, what it will do is go back to IP Fabric, again pull the inventory and configuration information relating to any devices or interfaces that may have changed between snapshots. If there is interface information that's changed, it'll make the calls into Netbox to update that information. And then it'll send a message into WebEx Teams. If there's any inventory that's different, because what it's going to do is create us two web pages, one with a list of all the additions in terms of inventory, and one in terms of the removals, the devices that have been decommissioned from the platform. And each one of those web pages will basically have a trigger on it to say go back to our script, so that we can then send some information through to Netbox as to whether or not we want the Netbox inventory itself to be updated as a result of those additions and removals. So we've got that ability to check and make sure that we do actually want to go ahead with those changes. So we have a scenario for our demo where we're at a point where IP Fabric is busy capturing snapshots of the network as we've described. Our initial load of Netbox has been completed, and so we have a script sitting in between the two, happily running and checking for changes and updates as we go. Now, we have an evening where we've got some changes coming up. Site 47 in our customer's network is no longer required. The office is being closed down because users are no longer needed to be housed there. They work from home most of the time now, right? So we're able to free up the office space and relinquish those network devices. So our change this evening will be to decommission those devices and shut them down, power them off, ready to be removed. As well as that, what we're going to do is in Site 48, we're going to expand the provision there in order to provide some hot desking space for the users who'll be displaced by closing Site 47. So yes, they're going to be working from home a lot of the time, but they'll still want to be able to come into an office at least from time to time. And so we're going to add some more switches into Site 48 in order to give those people some desk space they can use. And what we've noticed is, when we've been preparing for that change, that the distribution switch interfaces might need some attention. Let's have a look at those. Okay, so we're just going to have a quick look at Site 47 before we go ahead and decommission it. This is what it looks like. You can see there's a range here of routers. There's an MPLS connection. There's a bunch of switches as well, and a connection out here to going off to another site also. So there's a fair range of devices there that are going to have to be shut down and removed from the network. Now in Site 48, this is the site that we're actually going to increase the size of, and you can see already there's again a fair number of devices here. There's a bunch of layer 3 switches in the middle and some layer 2 switches around the edges, and what we're going to do is we're going to increase the port capacity by adding some more layer 2 switches. That means configuring these distribution switches, the layer 3 boxes in the middle here. So if we just have a quick look at those though, these interfaces need configuring, and wow, yeah, so those are descriptions look like they need changing as well, because these are meaningless, right? So our change then is going to update those interfaces as well as adding in our extra switches. As you can see here, what we have is we have a Linux box sat alongside our IP Fabric installation, and that's busy. Well, it's not busy at all at the moment. It's sat waiting for a webhook to come through from IP Fabric in order to kick off some activity. You can see here it's found the last loaded snapshot. It knows what it's looking for and what it's looking at the moment, and what the platforms, how the platform's set up, the connections established. So basically it's just waiting for us to make our changes and then go ahead and discover those changes once they're completed. And so that's what we'll do now. So this is after the changes have been completed. You can see here that the discovery process is just about to kick off, and we'll start loading the devices that it can find in the network after those changes have been completed, and away it goes. Now while that's busy doing its discovery, we'll just take a quick look at Netbox and just show that we can see the devices as they stand in the network. We can look at, say, Site 48. And we can see that we have all of the switches and everything loaded there at the moment. We can look at the interface information that we have about those distribution switches and see all of those dodgy descriptions there. And we can also go back and have a look at the information we have for Site 47. And we can see all of the information we have about the switches in Site 47's infrastructure as well, and they're all obviously in an active state. Now let's go back to IP Fabric, and you can see it's busy doing some loading, and we've got some activity already. So let's have a look and see what's going on. Yeah, so you can see straight away we've discovered that we've got some added devices. We've discovered that we've removed some devices. It's sent a message into the WebEx Teams room already, which is that little notification we've got, and there's another one there. And then we've just gone through and submitted our interface description message. So it's updated our interface descriptions as well. So now if we go to look at the diagrams, we can see that we no longer have the option for a Site47 diagram because the devices have been removed. They're no longer in the network. And if we look at Site48's diagram, you can see a difference. There are some extra devices shown here, switches 13, 14 and 23. And just to prove that point, if I switch back to the original snapshot, I can show you the interface names. There we can see the old junk ones. If I compare with the new snapshot, you can see our new devices that have been added and the fact that they're all now connected back into those distribution switches. And then if I flip to the new version of the diagram from the newer snapshot, we can have a look at those interfaces and see that those interface descriptions have names that make sense rather than the gibberish ones. So all good. So let's have a look at those messages in WebEx Teams. Okay, so all these interface descriptions have changed here, and so we've had to do something about those. So we'll have a look at those in a second. In fact, let's do that now. So if we go into Netbox and we go back to Site48, and look at those distribution switches interfaces, we can now see that we have interface descriptions that mean something because we've retrieved the data again from the platform, and that platform was updated in its snapshot after the change was completed. So all good, we've got that data through into Netbox. But what we don't have, let's have a look, is in Site47, all of our devices are still there and are still active. And that's because we want to go through this this verification process about what action we want to happen to those devices. Okay, let's go have a look at the other messages that have landed in WebEx Teams. So just up here, we've got the devices that have been added. We've got a link to follow to go look at those, and we've got similarly we've got a link to follow here for the ones that have been decommissioned. So let's follow those links. Let's have a look at the added forms. Right, okay, so clicking on add form here is showing me that I've generated this web page that shows me I have 3 devices that have been added to been detected by IP Fabric that need to be added to Netbox. So if I click on the green button here and then I go back to my script, I can see that we're busy now adding some information into Netbox. Now it may take a little while just because of the way the script runs. But you can now see that we've got a message here telling us that those have been successfully added, and a little message popped up in WebEx Teams there as well. So that's all good, and let's just confirm that. If we go back into Netbox, back to Site48, we can now see switch 13, switch 14 and switch 23 have all been added into Netbox, and we have those visible now. Now, something that has we also done here is we've tagged that with the identifier of the snapshot that it was loaded from, so we can differentiate when that was added into Netbox. Okay, great. What about the devices that have been removed from the network? What are we going to do with those? Well, let's have a look. If we click through on this, it brings us up this web page, which is another one that we've created, and this is all 21 devices that have been detected by IP Fabric that need to be decommissioned. Now, we could delete them from Netbox, But what we're actually going to do is we're going to change the state of them, because there may be some other physical work that needs to be done to go to site and actually remove them. So for the time being, we're not going to delete them. We're just going to mark them as being decommissioned. So if we click on the decommission button, we can then go back to our script, and you can see here we're running the process to decommission the sites, and that's now been done. There's our message. And again, if we go back to Netbox and now choose Site 47, you can see all of our devices are now showing as being in a decommissioning state, ready to be deleted and removed from the platform. And all of that done because we've got the data available in IP Fabric in order to distribute to other platforms in the ecosystem.